In this problem, we're going to do an application problem dealing with parabolas. So we have an engineer and he designs a satellite dish with a parabolic cross section. The dish is 16 feet wide from edge to edge at the opening, and the focus is placed 9 feet from the vertex. We need to position a coordinate system so that we can determine the equation of this parabola and then find the depth of the satellite dish at the vertex. First thing we want to recognize is that this is a horizontal parabola opening to the right with a positive p. So an equation we might use would be y squared equals 4px. Now, I don't need to apply my h and k because I'm going to set my vertex in this situation to be right here at 0, 0. So if I'm at 0, 0 right here when I'm at my vertex, and I know that the focus is 9 feet away, so there's my vertex, and I know that this focus here is 9 feet away. Since we're opening to the right, we know that that is a positive p-value, and we're going to be able to say that p equals 9. So in this situation, our equation would be y squared equals 4 times 9 times x. Or rather, y squared equals 36x. So again, just to reiterate, I set my coordinate axis so I could solve this problem with my vertex at the origin. And again, I knew that that focus was 9 units away, which allows my p-value to be 9. So here's my satellite dish with the parabolic cross-section, and it doesn't continue forever, right? You can see here that this satellite dish is not 9 units deep. It may not be to scale, but it's definitely not equal or even with the focus. So what we need to do is we need to determine the depth. And determining the depth of this means, and I drew another picture here, but it means that we need to know what this x value is. We need to know the distance from 0 to this upper, in a sense, height, but we're traveling on the x-axis. Well, one thing we know is that this is 16 units wide total, which means that the y value is either at positive 8 or negative 8. So all we need to do is to plug either of those in, and it doesn't matter which one because when you square it, they will both turn positive, into my equation that is modeling the shape of this parabolic satellite dish. So that gives me 64 equals 36x. Dividing on both sides, I have 64 over 36 equals x, which is the same as 16 ninths, or approximately 1.78. And that would be 1.78 feet. So depending on how the problem is asking you to round, you probably want to give your answer, though, in a fraction. So we'll say 16 ninths feet, or rather 1 and 7 ninths feet deep. And that's our final answer. So I hope that kind of helps you see how we can use these conic shapes to help us in maybe a diagramming or a modeling situation. As always, email me with any comments, questions, concerns. Ta-ta for now.